Morning, Husam.
Yeah, that's will be a intro. There will be a feedback when we talk.
Feedback. Oh.
Yeah. So what video is then it should be okay. But can you try talking your volume slow just.
Okay. Testing. You got your speaker on the side.
Yeah, it's probably you can bring your mic volume a little bit higher.
My volume, speaking volume.
Yeah. Your voice is a little
Alright. How about this level? Looks like I have to speak a bit louder.
Now it's better.
Now it's better. Okay. Okay, I have to get myself to this level of sound. But I hear echo.
Yeah, it's because of the video playing.
Okay.
So okay now. Yeah, there's still gonna be a video is still in the background.
Alright. Yeah, I can still hear some echo. When I speak, I can hear myself. Is that
Yeah. If you want to talk, then we need to stop the background.
Okay. Well, I can hear an echo of my own voice. Is it heard by the participants?
I think they can listen to us talking now. In the previous session, somebody giving a feedback in the platform. So they're supposed to come in with time, right? So probably these 29 people who are attendance is actually at this moment.
Okay. All right. Well, yeah, but what I'm hearing, I'm definitely hearing a lot of echoes as you speak. And when I speak, I hear myself half a second later.
Yeah. I blame the video. I think.
There's a chat coming in. The echo. Everyone is hearing echoes. We can't see the participants.
I think there's in the setting they switch off attendees.
Okay. Yeah, but I'm really still hearing echoes on my own voice.
Yeah, let's hope they once the video is switched off.
Okay.
And you sessions, and this would not be listening while we do this preparation. even from some
Husam.
last week. Sorry.
Got echoes.
Yeah, can you switch off the
Pardon?
background video though? Can you?
Oh, okay. Okay, can you speak?
Okay, I'll try.
So no echoes now, isn't it?
Yeah. Okay.
A bit, yeah, better now.
What's the problem just now?
You will start on 11.
No. What was the problem just now when we had the echoes?
I don't really know, but I think the slideshow, coming from.
Yeah, it's giving back the feedback from your slideshow.
Right. Okay.
So probably you can inform that across the board through all the Garis Pixel. So probably we have similar problem with the other sessions as well. And organizer. Sorry, PEM training. You don't have a name, do you? Oh, never mind. So we'll be starting in 4 more minutes.
Should I try and share my screen and see if it works?
Yeah, why not?
Yeah, okay. Oh, I cannot start screen share while other participants is sharing. Oh, okay, because the background is still on.
Yeah.
It's okay. Shouldn't be a problem. It's the same thing.
Okay. I think Lee Siong, you can. You want to start the video or should we start the session? I'll start the session first, huh?
Okay, sure.
All right. So good morning, everybody, and welcome to session 2 of the morning. And today, for this session, we have architect Chong Lee Siong, and he will be presenting. Let me get your title properly. It's on. Oh, I don't have it here. So your topic will be on fire safety design from outside to the inside, something like that. Excuse me for the title. Architect Chong Lee Siong obviously doesn't need any introduction, but as a matter of formality, I'll just say it anyway. He is the principal of Lee Siong Architect and graduated from Deakin University. And architect Chong Lee Siong has been instrumental in his role in assisting with the UBBL and also drafting the Red Book, which is the guide for fire safety design. And over the years, for the last couple of years, I think the matter for fire safety has been one of the bigger issue in our practice.
Oh, Husam, I think you're frozen. I think the connection is just gone off, Husam.
Sorry about that. I think I was disconnected. Just realized I was talking to myself. Yep. So excuse me for the hiccup. I'm connecting from home. It's not very stable. Yeah. So probably. Okay. I think I've introduced architect Chong Lee Siong. One of the things that is currently in discussion for fire safety at the current moment is the new requirements that has been coming out like every other week from the fire department, and also we've been a lot of there has been a lot of discussion on the delivery of construction permit, which also relates to fire safety requirement. And also there have been discussions on the new the new UBBBL that would be coming out pretty soon. So today we have architect Chong Lee Siong, who will be discussing on fire safety design that will be focusing on from the inside, from the outside to the inside. And even if you're well versed in fire safety design, if you've been in architect Lee Siong's session, there will always be something to take back. So I hope you will gain a lot. We have an hour and 30 minutes on this presentation. So we'll probably take the last 15 or 20, 30 minutes for question and answers. You can type in your question in the Q&A, but I suppose that we're going to answer them at the end of the session. And you can also raise your hand if you have any questions that you want to ask. Once we are at the Q&A, then we'll allow for the Q&A to happen. So we have 72 participants at the moment, and I don't want to keep them waiting. On to you, Lee Siong.
Okay, thank you, Husam. Yeah, before I share my screen, let's put some context to what I'm about to share with you today. Some of you may have seen this last year when I presented some snippets of this in last year's CPD sessions. Yeah, but see the situation with how our how the Malaysian bylaws, codes, and standards and bomba guidelines. See, the way it works is that our uniform building bylaws forms the basis of how we design our buildings for purposes of statutory approvals. Unfortunately, or okay, I wouldn't call it unfortunately. I just say that that's the way things have evolved. Due to probably due to a lack of an actual building code or an actual organization that can come up with a full set of comprehensive how shall I say a comprehensive set of standards that governs design. We have always been relying on the uniform building bylaws as the reference for fire safety, for building code compliances. I've said this many times. The uniform building bylaws is exactly what it says on the title. It's a set of laws. It's not something that can be, it is really not meant to be the definitive guideline or the reference material to learn about fire safety or to learn how to do a design properly. It's very much like I've also used this analogy many times. It's a bit like driving on the road. We are all supposed to be trained and be very good drivers before we get our driving license. But just knowing the highway code doesn't in any way make you a good driver, right? We all know that we have to stop at the stop sign. We all know that we have to give way at the give way sign, and we all know that if the highway speed limit is 110 kilometers an hour, we don't drive beyond 110 kilometers an hour. So we know all that. Those are all the laws. But unfortunately, the law cannot and will not be in any position to ensure that the guy who is driving on the highway at 110 kilometers an hour under torrential rain is actually driving safe or is actually driving correctly. Yep. So we have really over the years put so much emphasis on learning the bylaws and drawing the line. Okay, the bylaw says this. Okay, so is what I'm doing, does it comply with the bylaw? Doesn't it comply with bylaw? Yeah, but unfortunately, by doing that, we've also lost a lot of the understanding of what is the nature of fire safety and what are the things that we ought to know about how we approach fire safety and how our buildings ought to be designed in the first place. Yeah, so we should be taking the bylaw as as just a cutoff point. It's just a set of laws to define um, to make the definition whether it's deemed to be approved or not. Yeah, there are just so many other aspects to it before we even arrive at that point of checking our things against the bylaw. Right? So what I'm trying to do today is to explore these particular two areas in terms of fire appliance access. Fire appliance access, we've done it all these years by building volumes and saying that, oh, you must have a perimeter access around the building to comply with the bylaws. Yeah, and this one in recent years has caused an awful lot of confusion, an awful lot of debates, and especially as our buildings get so complicated, volumes get so big, buildings get so tall, and we start building on, say, slopes and buildings with different levels, multiple levels of fire appliance access, multiple entries, and things like that. Just complying with the base bylaw, it leaves just way too much things to be interpreted. Like I said, the bylaw just says that you can drive at maximum speed of 110 kilometers an hour. It doesn't tell you in any way when do you have to drive at 40 kilometers, when do you have to drive at 60 kilometers an hour, etc., etc. Yeah. So what I'll be doing is I'll be sharing with you first on the basis of the bylaw. Then from there, what exactly is the intention of setting certain criteria, and then from there we're able to work back and yeah, let's hopefully we can try and understand a little bit more as to what it means to be fighting fire from the outside, and why is it so important that certain buildings requires the full plethora of active systems for the fighting of fire from the inside, right? Okay, let's I'll try my best to go through it from here. Okay, at any point in time, if you do have questions and all that, just quickly put it into the chat. I think that the chat is open. Husam, the chat box should be open. So yeah, at any point in time, you have any questions and all that, just put it in the chat box. Then when we go to the Q&A session, we'll be able to then run through it and answer those questions. Right. Okay, designing for firefighting access. Okay, first part I'll bring you on the applications of fire appliance access. That means it's designed for firefighting from the outside. Yeah. Okay, the bylaws, the UBBL, the revised UBBL 2012 has brought in just a few more clarifications with regards to the application of fire appliance access. If you recall, the original UBBL, the 1984, the width of the fire appliance access is actually 12 meters. It's not 6 meters. It's actually written as 12 meters, and that the building is supposed to have a fire appliance access in the proportion as specified relative to the building volume, and the fire appliance access is to have width of 12 meters. So it was a prescribed width. Yeah? But of course, in practice, we have always used 6 meters, or minimum 6 meters, we call it. Now, the UBBL 2012, the revision, clause 140, it now says that access way shall be provided within the site of the building to enable fire appliances to gain access to the building. Now, that's actually the key word over here. The access way is to enable fire appliance access to gain access to the building. An access opening shall be provided along the external walls of buildings fronting the access way to provide access into the building for firefighting and rescue operations. See, that is the key. This is the key as to what an accessway actually is. It is not just a driveway around the building. The intention is that it is to be designed such that it provides access to the building, to number one, and second is access openings shall be provided along the external walls of the building, fronting the accessway to provide access into the building for firefighting and rescue operations. So here, you notice that the external fire appliance access is to for firemen to gain access to the building, both externally and access into the building. Right, so it's actually fighting fire from the outside and from the inside. That's what's the purpose of the appliance accessway in one broad sweeping sentence. Okay, the physical requirements of the accessway. It says accessway shall have a minimum width of 6 meters. The key word here is not the 6 meters. It's not the prescription of the 6 meters. The key word here is actually minimum width. In other words, the width of the accessway shall have to be designed to be appropriate for the firefighting activities of what the firemen would be expected to be doing when they arrive at your building, right? We have, I think, the majority of us would have taken 6 meters like an absolute prescription. We draw a square box of a building, we draw two parallel lines 6 meters apart, circle it around the building, and there we go. We've got our fire appliance access. So no, that is not the intention. Yeah, the keyword here is minimum width. It's minimum 6 meters, but it shall have to be of the width, whatever is necessary. throughout its entire length, in other words, throughout the entire prescribed length of the fire appliance access for your particular building, and shall be able to accommodate the entry and maneuvering of the fire engine, extended ladders, pumping appliances, turntables, and hydraulic platforms, as may be the case relevant to your building type. So here it puts the onus on the submitting persons, i.e. on us architects, for us to first recognize what building type is this that we are doing. The volume of the building, the height of the building, and the kind of a building that you're actually doing. Is it a factory? Is it a shopping mall? Is it residential accommodation? What purpose group of the building is, and which portions of the building, which portions of the perimeter is of what purpose group, because that would then determine what would be the appropriate fire appliances that bomber would be sending to your building to fight the building, to fight a fire in your respective building. Right? So therefore, the access way is not just a road of 6 meters surrounding the building. It is, for all intents and purposes, had to be designed for the purposes of fire appliances to gain access to the building, and for firemen to be able to gain access into the building, and the accessway has to be designed to accommodate the entry and the maneuvering of the appropriate fire fighting appliance that would be arriving at your particular building to fight your particular kind of a fire in your building, right? So these are the key. The rest of it are then just prescriptions to handle this part over here. Yeah? So that's what the law does. The law just gives you a prescription, but the law doesn't tell you, or you won't be able to learn from the law what would be the appropriate way to design it. Okay, that's really what it does. That's the nature of the law. Okay, in terms of prescriptions, these are the little additional clarifications that is found in UBBL 2012 over and beyond 1984. The accessway shall be positioned so that the nearer edge shall not be less than 2 meters from the face of the building, or nor can it be more than 10 meters away from the center position of the access opening measured horizontally. In other words, whenever you design your accessway, the inner edge of your demarcation of the accessway, of your measurement of the accessway, shall not be nearer than 2 meters to the face of the building. In other words, you cannot start the width of your accessway from the face of the building, right? You must have a minimum 2 meters separation, preferably a hard edge. And in any case, the hard edge itself cannot be more than 10 meters away from the building. So in other words, what they're really saying is that there should be no less than 2 meters from the edge of the accessway to the face of your building, and no more than 10 meters away from the building. Yeah, so that means the furthest you are allowed to be separated from building is 10 meters, and the closest you're allowed to get to is 2 meters. That's the edge of the accessway. And the accessway shall be laid on a level platform, or if on an incline, to a gradient of not exceeding 1:15. And the access road shall be laid on the incline not exceeding gradient 1:8.3. So here we see that there is now a clearer definition of an accessway and a definition now of an access road. The dead end accessway, okay, if you have an accessway which is not going to turn around the building, it's a dead end, okay, shall not exceed 46 meters in length. If it does, then you do have to provide turning facilities. So in other words, you do not want a fire engine, or you don't want one bomber to enter the accessway, drive more than 46 meters and find that it's an it's a dead end and they have to reverse all the way back. All right, that's the intention over here. And the rest of it are just prescriptions. Overhead clearance of fire engine access road shall be at least 4.5 meters for the passage of fire appliances. Now, this one referring to the access road, right? So here, what we see is that in just this one new clause, we've got the definition now of an access way, we've got the definition of an access road, and we've got the prescription of an access opening. It doesn't actually prescribe how you locate access openings, but it's given now the relationship between the accessway and the building, i.e., you require an access opening. Yeah, what this clause actually says, this one here, right? Sorry, the at the start over here, fronting the accessway, provided with the access opening shall be provided along external walls of the building fronting the accessway. What really this one means is that if you're designing a building with a full fire rated wall fully on one side, say on one of the elevations, without any access openings, without any openings whatsoever, it's a full wall, a full fire rated wall, solid wall, where there's no risk of fire burning out onto the exterior, and there's no way for people to even get inside. You don't actually need an accessway fronting that particular part of the building. Okay, this is really what it means, because it is meaningless to have an accessway fronting a blank wall. Right, that's really what it means here. Right, now we look at the other prescription then. Right, fighting for firefighting measures to fight fires for building over 80 meters high. Buildings in which the topmost floor is more than 80 meters above fire appliance access level shall be provided with the means of gaining access and firefighting from within the building, consisting of firefighting access lobbies, firefighting staircase, fire lifts, dry and wet rising systems. Okay, this is now, we are all very familiar with this. This is really talking about the provision of firefighting access lobbies, FFAL, for buildings above 18 meters, for buildings where you have floors higher than 80 meters from fire appliance access level, right? So this one, the reference is to building height. The prescription for fire, the access way is based on building volume. The prescription for the FFAL is based on building height. Now, both of these prescriptions are totally independent of the purpose group of the building. It doesn't matter what building you're building. The provision of fire appliance access and the provision of FFAL, it's just reference to the volume of your building and the height of your building. Right? That's a very important note over here. Right. Okay, let's look at the fire appliance access now. Now remember, now we've got the definition of an access way. So access way, these are my own definitions now. These are not the definitions from the UBBL itself, right? So an access way is really an area for the entry, maneuvering, and parking of fire appliances during firefighting and rescue operations. An access road is a road capable of accommodating the passage of fire appliances to enter an access way. And access openings are doorways or openings that allow fast and safe entry of firefighting and rescue personnel into the building during firefighting and rescue operations. Right? Now, all three of these items will have to work hand in hand in our design for the purposes of designing for firefighting from the outside of the building and from within the building. I'll take it as a bit of a parallel. If you consider when you're designing, say, a car parking a car park. Okay, if you're designing a car park, the access way would be the equivalent of where you have your car parking bays, including the frontage to the car parking bay for you to maneuver your car into the car parking bay, right? I will take that as the equivalent of a car park arrangement. The access road, on the other hand, are like the ramps, the main ramps entering into the car park, right? To the point where you can enter a particular car parking floor and then enter into the circulation of the car parking floor where you're going to eventually park your car. And the access openings are, after you parked your car, the pedestrians or the, the occupants of the parked car will have to find a way to enter the building. You park your car there, you have to then now enter the building from the car park. Or if it's solely a car park, you have to exit the building. You have to exit the car park to get onto the ground or to wherever you want to go. Right. So these will be the parallels. See, when we design car parking bays, yeah, we have the car park bay that's designed, but we also need to have the appropriate immediate circulation for a car to maneuver into the car parking bay, right? Whether reverse parking, parallel parking, or angle parking, right? You need the space in front of that particular bay for the vehicles to be able to maneuver itself into the car parking bay, designated car parking bay, right? And you need access roads, ramps, external roads, gates, uh, ticket going past the ticket machines or ticket booths or whatever, to be able to bring vehicles into the area where you're actually going to maneuver and look for your car parking bay, right? And again, access openings, after you park your car, you have to enter the building proper, away from the car parking. You have to get out of the car park to enter the building proper. Okay, use that as a parallel in our understanding. Right. On the external access, when we talk about bomber access, we're really talking about bomber and any other rescue personnel. Access for emergency and rescue vehicles, equipment and personnel. So it'll be consisting of roads, pavements, parking, and the availability of water. Yeah, will be hydrants, storage tanks, lakes, rivers, ponds, and access to firefighting systems within the premise. That's fighting fire from the inside. So when you arrive at the premise itself, there should be clarity of the type of building and function, the configuration of the building, clear visual signs or clear visual indications as to the configuration of the building. Where's your main entrance? Where are the access openings, etc.? A location of fire control panels. Where's the guardhouse? Where's the main fire control room? Location of breaching inlets and pump rooms. Where are these things? Are they clearly marked? Are they visible? Are they accessible? And access into the building via protected passages, protected stairs, fireman's lift, and firefighting access lobbies. All right, just very quickly recap what are all the systems that would possibly be specified under the 10th schedule for the purposes of active firefighting installations. On the outside, where specified, you have a pressurized hydrant system, and then the pressurized hydrant system will then have its own storage tank. You'll require the pumps, and then you'll require the breaching inlets. Sprinkler systems are very typical installation. You have the sprinklers, which will then you'll have these tanks, these storage tanks, these fire pumps, and breaching inlets. Dry riser system, dry because it's dry, so it doesn't have any storage tanks. And if there are no storage tanks, there are no pumps either, right? But you do need to have the breaching inlet for you to be able to bring water, to pump water externally into the riser system if it's dry. Of course, if it's specified as a wet riser system for buildings above 30 meters, you must have a wet riser system. You cannot rely on the dry riser. Right? Then you'll have its tanks, you'll have its pumps, and you also need the breaching inlets. So the whole diagram will work in a very, very simplified way. It will look a bit like this. You'll have the access way, breaching inlets to connect into where you have the internal tanks and the pumps that connects to the sprinklers and the risers, the wet risers. Okay, hose reels will not have breaching inlets. Hose reels are first aid, so hose reels will have their tanks, they'll have their pumps, but they will not have a breaching inlet. In other words, hose reel is really meant to be used by the occupants of the building. You and me, we can use the hose reels to as a first aid to fight the fire. If the water actually runs out, yeah, you better leave the building by then, right? Because the firemen will be coming in, and they will take over, and they will use the risers. Okay, that is the man tool. Okay, these are boys' tools. All right, so just remember that. Of course, then the breaching inlet will have to be accessible. So the whole thing, the way it works is that if there's a fire, when a fire does occur, if you and I are brave enough, we can use the fire extinguishers to try and put out the fire, or if the situation is tenable, we can start to use the hose reels as a first aid to fight the fire, right? Or if the sprinklers may be activated, right? So these are what it means. This entire system here doesn't matter whether it's sprinklers, hose reels, whatever, they are all working in the same principle. You have the internal storage water, you have the pumps, and these will then be able to be used for the purposes of fighting the fire on the inside. First aid before the fireman arrives. When the fireman does arrive, eventually, actually the response time is very fast nowadays. They're keeping a KPI of less than 10 minutes now. In most times, they're averaging about 11 to 12 minutes. Yeah, so the firemen are very, very capable now. In most situations, they are able to arrive very, very fast, traffic permitting. So when they arrive, this is really their playground, the access way. So the access way is really like your parking garage that you're going to create only solely for the use of the firemen. So when they arrive, they would then be where the fire engine parks. These are called the staging areas. The fire engine will be parking in the position for the sole reason. But the fire engine is actually a water pump. Right? Is what makes a fire engine is the water pump. Of course, it carries a lot of other equipment and all that, but primarily a fire engine means it's carrying a water pump, a very, very large capacity water pump. The whole intention is that you'll be able to then connect the external source of water into the fire engine, and from there you'll be able to then use the pumps to fight the fire from the outside. But more importantly, you'll be connecting to the breaching inlets. Right? The pump from the fire engine connects to an external source of water to pump it through into the breaching inlet to replenish the internal tanks of the active systems. And when bomber arrives, of course, you'll be replenishing the sprinklers. That's very, very important. But when bomber arrives, what they really, really want to do is to be able to then connect the external source of water via the pumps to pump it through the breaching inlet to the risers. If it's a dry riser, they'll need this water immediately to fill up the risers. If it's a wet riser, they will need this water as a standby to immediately replenish your internal storage, your internal water storage. So Bomba will be able to use that, and they'll have a constant source of supply from the outside. Okay, so this is the relationship between these systems. Now, in terms of the design, where the prescription of the bylaw is this. We are still working by volume. So you've got a volume of the building. From there, you will determine whether what is the the proportion of the perimeter of the building where you would then require a frontage to the accessway. So using this example, let's just assume that the volume works out that you will need this frontage, say a quarter, right? You'll need this quarter frontage to an accessway. So this becomes the face of the building that would be required to front an accessway. And then you have to design an accessway to front that required face of the building. So accessway, minimum, okay, I have to emphasize the word again, minimum. It's minimum. It may be more. You may need a lot more. All right, but it's minimum. You start off from 6 meters. Okay, the prescriptive load in terms of how you design the driveway, gradient not steeper than 1 in 15, and zero overhead obstructions. Absolute zero overhead obstructions. Access road from the circulation of bomber or whatever to be able to bring them into this access way. Minimum width, I'm suggesting 4.5. This is not prescribed in the UBBL, but Bomba has been issuing a lot of guidelines with regards to the design of access roads into gated buildings, gated communities and all that. And the guidelines dictate that if you have to pass through, if you're getting Bomba to have to pass through an archway or a gateway, the minimum unobstructed width shall be 4.5 meters. And the minimum overhead clearance, and this one is specified in the bylaw, shall be minimum 4.5 meters also, right? So you need minimum 4.5 meters width and minimum 4.5 meters clearance. So if you have to do an archway, this is the minimum dimension, right? 4.5, 4.5. And the gradient as specified in the bylaw shall not exceed 1 to 8.3. So that would be the relationship. And then very, very importantly, on the face of which you have designed to be the face where you're having the fire appliance access, you must then locate access openings. Now, how do you locate the access opening? Okay, we go into that just a little bit later, right? Now, and the edge of the accessway. This will be the width of the accessway. The edge of the accessway will then have to be minimum 2 meters away from the face of the building, but not more than 10 meters away from the face of the building, right? So the edge that you demarcate shall have to be anywhere between 2 meters to maximum of 10 meters from the edge of the building. Now, if you have another scenario, let's say, for example, this building requires 50% of the perimeter for an accessway. And this building, for some reason, is designed on a slope, and you've got two different levels of fire appliance, right? You've designed the building where there's a fire appliance access level here at the lower ground, and behind you have another set of frontage for an accessway, and it's at a higher ground. So this is what you have to do. You basically have to repeat all of these things across the other face of the building, right? Then you'll have to find some ways to get access, of course, to that part of the building, right? This connection is not specified in the bylaw. It doesn't actually say that you must connect the two accessways, but this is always a recommendation for the purposes of the practicalities of how Bomba will fight the fire and how they maneuver across this place. Where possible, I would suggest you do look for ways to connect the two accessways at the two different levels where they're coming in from two different access roads, right? I would suggest, yeah, seriously do consider finding ways to be able to connect these two accessway platforms via an access road, right? Just again, remember that the gradient is limited to 1 to 8.3, and observe the overhead clearances and the minimum width required between obstacles, between gate posts or between curbs, etc. etc. Looking at it into further detail now, when bomber actually comes to the access way, right, this will be the designated access way, and designated access ways will have to be labeled with these huge letterings painted on the floor. Say Laluan Jentera Bomber, Kosongkan Laluan. Okay, this is all mandated, and from there, this is the relationship then to fighting fire from the inside. You have the firefighting shaft, right? You need the location of the pumps to be accessible from the access way. Emergency power generators, because with the pumps, it'll be the location of the physical breaching inlets and the location of the hydrants. Of course, hydrants are hydrants, we all know, is 90 meters along the access ways. But however, what is more important is that the nearest hydrant to the breaching inlet, or rather, to put it another way, wherever you locate the breaching inlet, you have to have a hydrant within 30 meters, absolutely no more. Within 30 meters, in the manner in which you can lay the hose to a hydrant, from breaching inlet to the hydrant, right? And the precise measurement is actually from the coupling of the breaching inlet physically to the coupling of the hydrant. It cannot be more than 30 meters, right? That is very, very important. And then you have the location of the access opening. Now in this case, it's very, very convenient. You have the fire appliance access, you have the FFAL, or the firefighting shaft, come through a lobby or through a protected passage and all that. That would be an access opening that the fireman would want. And that would have to be then be fronting to the fire appliance access way, and that horizontal distance, the tangential distance from the access opening to the edge of the fire appliance access way, shall not be less than 2 meters and shall not be more than 10 meters. Right? That is very, very important. Okay, now if you look at the UBBL, we are all familiar with this chart. By volume, for all building types, these are the prescriptions of how much of the perimeter frontage you will require of the building to front an access way. So this is by building volume. Now let's look at a few scenarios over here as to how it's applied. Looking at a high rise, let's say there's a plinth of 30 meters and by 30 meters. So it's about 100 feet by 100 feet kind of building. Very, very small plinth, right? 30 meters by 30 meters is less than 1,000 square meters of a floor plate. Okay, it's a small plinth building, but it goes up very high. So when it goes up to say 30 meters, by this volume, 27,000 cubic meters, the bylaw will prescribe a frontage of 1 over 6 of the perimeter frontage. So okay, this is the frontage, and that would be approximately 1 over 6 of the full perimeter. All right. If I increase the building height, if I double the building volume to 54,000 cubic meters, I will require a quarter. So a quarter would be, I have to extend it a little bit. So that's a quarter over there. So I got this frontage, which is a quarter of the perimeter. If I increase the building height to 90 meters, I would then, on the same plane, I would then have 81,000 cubic meters. And 81,000 cubic meters would then require half of the perimeter to have a fire appliance frontage. So that's the half of the frontage that I'll require. Right? And so on and so forth. If I go a bit higher, I go to 108,000 cubic meters. Okay, that would be quite a tall building now. It's 120 meters high. I will require 3/4. So there you go. I have that 3/4. If I go even higher than that, super tall building now, 150 meters high, 135,000 cubic meters, and that will be an island site. So there you go. So we have an island site, right? Now, if you look at this situation over here, this is the prescription on the application of the fire appliance access way relevant to the face of the relevant to the volume of the building applied in terms of a proportion to the face of the building. Now, if I have a fire burning inside the building, say at a high level on that side of the building, and the fire is actually leaping out of the windows opening on that side of the building. If you come to this building, you have this perimeter access limited to just that part here, and firemen have got no way, say, to go to the other side. What would the firemen be doing? Now, remember, this is a 30-meter high building, so obviously there will be the firefighting shafts already installed in here. You'll have the wet risers already all installed in here, right? So the purpose of this access way then would be really just to bring the firemen here for them to be able to hook up their the hydrants to the fire engines, to the breaching inlet. So hopefully your breaching inlet will have already been installed, right, somewhere here within 30 meters of the nearest hydrant for them to be hooked up in there. Then the firemen will have to enter your building here somehow, right, through an access opening to reach the firefighting shaft to be able to take the lift up to the relevant floors to be able then to fight the fire from the inside, right? Now, this building has got exactly the same plinth. If this building is that much taller, a fire happens over there, what would be the firemen be doing? They would be doing exactly the same thing as they would be doing with this building. In other words, they need to be able to enter the building from a safe distance to get into the firefighting shaft, to be able to bring them up there to be able to fight the fire from the inside. Okay, so the island access on this building, not to say it's not required, but really the risk and the manner in which the firemen will be fighting the fire from this building, from this to this, will be exactly the same. In fact, what I would say is that because this is a lower building, if a fire occurs at the lower floor, I would actually prefer the appliance accessway to be an island on this building instead of on this building. Because on this building, it's such a tall building, I would have had a full criteria of the design of firefighting from the inside of this building. It's no point fighting the fire from the outside if the fire is burning at that level, right? So I would say that if the building is designed in exactly the same manner, for this building, the 1/6 fire appliance frontage is probably too low, right? And that would be my suggestion. But of course, if you do this one, you're not breaking the law. Right? You're still in full compliance of the law, right? Let's look at another scenario, a low-rise building. So this building plinth over here, exactly same volume, 27,000 cubic meters, 1/6 of the frontage. This building, much lower, but it's got 3 times the floor plate, and it's also long and rectangular. 27,000 cubic meters, exactly the same volume as that building. It still requires 1/6, and this 1/6 of course is a little bit longer because it's 1/6 of a longer perimeter measurement, right? So so you have this situation. When it comes to this building, 54,000 cubic meters, 1/4, so that's 1/4. All right, so if I put the same volume on this building, that's 54,000 cubic meters, and I require 1/4, and that would be my 1/4. That will comply because it's 1/4. So if a fire burns on this end, on this building, if a fire burns there, I've got the access, or rather the firemen will have access via the access opening vertically up the fire shafts firefighting access lobbies to fight the fire on the upper floors. But if I have this low building, which is only 2 floors high, I don't have internal firefighting lobbies. I'm still complying with the prescription of the bylaw by having only 1/4 perimeter access, which is over here. So the firemen, when they arrive at the building, they have to find a way to enter the building, find a way to go all the way to the end, and to try and fight the fire from here. And the possibility is that with a building of this volume, depending on this purpose group, it probably only got hose reels inside, right? And the hydrants will be located along over here. If you locate a hydrant over here because of complying with the 90 meter, and you don't provide the fire appliance access to the hydrant, then it becomes useless. So what I'm really saying is this: the basic compliance just with the bylaw, without thought on how the fireman fights the fire, would not exactly be the best way to approach the design of a building, right? Because that would be too far for the fireman to reach, right? So compliance, the minimum prescriptive compliance, does not necessarily mean you're complying with the required performance. Yeah? So of course, Bomba is they are definitely very well versed in this. So very often when we submit plans and all that, there'll be a lot of conflict sometimes when we go for minimum compliance, and then Bomba say, oh no, you need to do this, you need to do that, you have to add this and that. Then a lot of times we will end up arguing with Bomba and say, oh, but the bylaw only asks for this. Why are you asking for more? Right now, this is the precise situation, right? When a situation like this actually does occur. This is hypothetical, of course, but it can happen, right? You would think that you've complied to the minimum requirements of the bylaw, but that minimum compliance does not fulfill the performance criteria. So if you look at a picture like this, a fireman typically fighting fire. If you just go minimum compliant, minimum 2 meters, minimum 6 meter access way, are we still designing to minimum prescriptions? That's the key thing. Fighting fire from the outside, you look at the kind of space that they have to park, right? See, on the contrary, the lower the building, they would actually require more width, because they would have to then park the vehicle in a manner to be able to reach that. Right? A higher building, on the contrary, they actually require a little bit less width. Yeah, but they will always require to have multiple fire appliances to be able to connect the hoses, right, from one pump to another. And depending on the capacity, they might need to start connecting the pumps in parallel to be able to boost up the pressure as they may require. Right? A general configuration on how they park the fire appliance access. Right? Now, I want to bring you to the Singapore codes. I'm not saying that we are adopting the Singapore codes, but recognizing what Singapore is doing gives us a very good idea on what we should be designing, right? Don't just comply with the minimum bylaws. By having understand these things, we should be able to design it in a better manner. Okay, now in Singapore, for building under purpose groups, other residential, office, retail, and places of assembly, they are relying on the floor plate area of the building, the plinth area or the floor plate area of the biggest floor as a means to determine the perimeter access for fire appliances. Right? Proportion of the perimeter access is determined by a floor plate area instead of by the volume of the building, particularly for other residential, shops, other residential, offices, shops, and places of assemblies. Right? This is the Singapore code. Now, it is in no way contradicting the bylaws, right? But it is a way to check and just to ensure that you're not in any way that you are designing it to be appropriate, right? Let's take some examples over here. Our previous example that we had, this is an example where if you have used the volume calculation will require, what is it, 1/4, 54,000 cubic meters, 1/4, and we end up seeing that our fire appliance access way may be only be limited to this corner over here. If you use a Singapore code using the floor area, this floor area has got 5,400 square meters, and the Singapore code will then require half of the perimeter of the building to be serviced by the access road. You see, this is the main difference. Yeah? So applying a performance criterion to check on your prescriptive codes can often lead to better designs. Right? If you walk into Bomba, if for example you are designing a building that looks like this, and you come up with this, Bomba looks at it. If they spot it, they'll say, "Hey, ini tak boleh lah. We need to extend it." But if you go to Bomba and you say, "Oh, really, UBBL asked for 1/4, but hey, tengok sini ya, I check on the Singapore codes and saya bagi you ini," right? You'll get your approval immediately, right? Because Bomba will then recognize that you have designed your building not just to the minimum compliance, but you have actually considered what is the physical requirements of fighting, of what Bomba requires, for your building to be safe. All right, so I'll quickly run through now on the firefighting from the inside. Okay, give me 10 minutes, then I'll open it up for question and answer. Okay, so that's on the outside now, which is just defining the frontage to a access way. Now, what's more important is that when you get inside the building, as we mentioned all of this before, when you get inside the building, okay, all of these things are the outside. What you design on the outside is, remember, access way, hydrants, location of your breaching inlets, and the access openings. Okay, that is what you have to handle from the outside. On the inside is then the firefighting lobbies. If you have a small residential house like this, where got firefighting lobbies? Right? We don't even have fire extinguishers inside our house. So what fighting fire on the inside? There's nothing with regards to designing for firefighting from the inside if you just got one single house. Why? Because it's such a small house, right? The occupants, you should be able to escape out of the building already. When the firemen come, their primary job is probably not to save your building. Their primary job is to ensure that your fire does not leap to the neighbors, right? You'll notice that when firemen come, they will not exactly be saving your building first. If the occupants trapped in there, they will want to save the occupants. But if there are no more occupants trapped inside the building, they're not worried about putting out the fire in your building. They will be splashing water, spraying water, and cooling down the buildings on both sides to ensure that the party walls are holding up and that the fire will not leap to the adjacent building. Right? Your building can burn down for all they care. Fighting fire on the outside, like you've got a high-rise fire like this. You see how far away are the fire appliances parked from the building, right? It's not 6 meters down there. They don't park down there. They are really far away because they're not primarily fighting the fire from the outside. On the outside over here, what they're doing is that they're cooling down the adjacent compartments. They're splashing water on the adjacent compartments, and if they can actually see the fire leaping out of a particular opening, they will be shooting water through there to try and cool it down. But really what they're doing on the outside is just cooling down the adjacent compartments, right? The actual firefighting will occur on the inside. The firemen would have already gone in there, up the lobbies, and to fight. Now, on the other hand, for low-rise buildings like a factory or a shopping mall, right, where it's long and wide, precisely in the example that I've given you on the Singapore code, the intention is that you need to have fire appliance access very, very important, because you will then need to be able to have these booms to reach from above to fight the fire from the openings on the from the roof or from the upper levels. Okay, there'll be smoke vents, or the fire will be burning through the roof and all that. They need to cool down the fire from above. Right, that is the intention. Right. Similarly, in this situation, say how far away are the actual the actual sky lifts parked? You know? They're parked very, very far away. And these appliances you can see down here, they are parked nearer to the building, but they're actually very, very far away horizontally. They're nearer to the edge, but horizontally they're actually very far away from the frontage of the building, right? Because they're connecting all the hoses from hydrants to pumps, parallel pump to another pump, right? To connect the hoses to ensure that they got sufficient water. Likewise, this one here, these things are not of any help, right? This boom over here is, again, like I mentioned, is just to cool the building. Like you see, in this configuration of the building is so tall, right? There's no appliance access on this face of the building, right? Does it matter? In my opinion, it doesn't matter, because there's no reason for you to want to reach there anyway, right? The fire will be fought from the inside already in a situation like this. Right, so the Singapore Code have a clearer definition on how you apply access openings. Right, our Malaysian code is absolutely silent. A bit of a background on this one. Don't quote me on this again. When we did the revisions to clause 140, it actually had the prescriptions of access openings, right? Because we literally took the Singapore Code and we studied it, and we thought that we could actually have it apply it lock, stock, and barrel. But Bomba were not too confident at that time to make that prescription. So therefore, the precise prescription for access openings is taken out of the UBBL 2012. Right? But then again, just having a look at the Singapore codes will make us understand what is it that we can do. If you've ever traveled to KLIA, you would have noticed that along the departure halls, on the perimeter glazing, and every so often you'll see a glazing with a bright red triangle on the glazing. You'll be wondering what that one is for. That is actually marking the access openings. Right, that means that piece of glass is tempered only, it's not laminated. Bomba can smash it and get access into the building. The Singapore Code dictates that horizontally you'll have to have access openings at maximum 20-meter intervals, up to a building height of 60 meters. And anything above 60 meters, they're saying that don't bother giving any access openings from the outside, because nobody can reach you anyway. So access opening is provided up to 60 meters, and horizontally maximum at 20-meter intervals on the frontage facing your design appliance access way. Right? This is the application of Singapore. You can see that these little triangles over here. Right? So these are the access openings, and of course there are a lot of prescriptions on the access openings. It has to be accessible by the firemen on the outside. If you have a piece of glass, it cannot be a laminated piece of glass. Neither can it be just float glass. It has to be tempered glass, where the fireman can smash it and get access. If it's an opening panel, then it has to be a panel whereby it can swing out of the way when you open it. If it's a drop panel, something that you actually remove, it has to be then tethered. In other words, you don't expect the fireman to come in here, remove the panel, and then throw the panel down down onto the ground. Right? You can't do that. Right? If it's just a removable panel, it has to be tethered. Right? That means you remove it and then you'll be hanging via a tether, so that it wouldn't drop down to the ground. So there are various prescriptions. On the external part, for example, all these are from Singapore. Yeah, you have external cladding or louvers and all that. So you do also have to identify which are the panels that are to be openable. right? And they do have very specific guidelines as to what is allowed or what is not allowed. The primary thing is that it has to be able to be either smashed open by bomber. Not in Singapore, it'd be the civil defense. It had to be either being able to be smashed open straight away and have a clear opening, or if it's something that can swing open, it had to be swing open in a manner that will not obstruct the entry. If it's something that has to be removed, it must be teetered so that it will not drop down to the ground. This guy is probably on the 15th or the 20th floor of the building. So there you go. Right, this is actually a fire appliance access panel. Right. Yep, guys, happily enjoying his coffee there, knowing that he'll be safe. If there's a fire, he can smash this one and he can jump up from here. No, that's not meant to be the purpose. Right, yeah, so coming back to what I mentioned earlier, the key element here is the access opening relative to the fire appliance access way. Right, access opening leading you to a firefighting shaft or leading you to parts of the interior of the building. In terms of the application of the firefighting shaft, we all know that if the building is above 18 meters, you need a firefighting shaft. From 80 meters to 30 meters, you can make do with just a dry riser. Right? Above 30 meters, you must have a wet riser. Now, in most of my projects now, even if I just cross 18 meters, I would usually go for a wet riser already. Right? Because yeah, if you can do it, why not? Right? If you have lower basements below the fire appliance access level, you do not need a firefighting shaft if your basement does not go deeper than 9 meters. If your basement is deeper than 9 meters, then you need a firefighting shaft, right? So it's a combination of the building height. You need a firefighting shaft to accommodate the above ground level of more than 80 meters, and you need a firefighting shaft to accommodate lower ground or basement levels deeper than 9 meters. Right? So you can have combination like that. And where your building is both taller than 80 meters and deeper than 9 meters, then you need firefighting shafts. And the firefighting shafts will have to be a separated shaft. It cannot be one single shaft, one continuous volume from serving the basement to the upper floors, right? You do have to separate it, and the physical interface will, of course, be at the fire appliance access level. If you have buildings on where you have two different fire appliance access levels, okay, that is how it's supposed to go, right? The exposed space over here, that would have to be then regarded as the basement because it is below the fire appliance access level and you got no more fire appliance access from this side, right? But if you have fire appliance access levels on both sides, then it'll be one continuous shaft going all the way up, and you have the fire appliance access levels on both that locations. Right? These are general diagrams that you may use for the purposes. Of course, we know in terms of building designs, there are so many different configurations. As architects, we are so creative in terms of how we work out our interior volumes of the building, right? Fantastic. By all means, do so. Yeah, this one will serve just as a general guideline as to how we apply how we design in the fire appliance access levels. The firefighting shafts relative to the fire appliance access ways. In terms of the location. Now, as we speak, the revised UBBL is supposed to have rationalized the prescriptions on how we locate or what are the limits of distances and all that we ought to locate for the fireman's lift, the firefighting shaft, risers, etc., etc. Right? But as it stands today, the specifications or the prescriptions are not exactly contradictory. In fact, they are not. We have the law prescription from the UBBL, and we also refer to Malaysian standards 1183. Yeah, they are not contradictory at all. In fact, they're just a different way of describing the same thing. As I said, the UBBL is just a law. It just prescribes something. It's a law. The Malaysian standards, obviously, as a set of standards, it prescribes, it does guide us into a lot more as to what are the reasons we do certain things and what are the ways in which we do certain measurements. Right? Okay, for example, in the Uniform Building Bylaws, in terms of location of the risers, it says all parts of the floor must be within 45 meters from the landing valve. And the firefighting access lobbies, the level distance from the furthermost point should not exceed 45 meters to a firefighting access lobby. When it comes to the fire lift, it says a fire lift still in the UBBL, a fire lift is not to be not more than 61 meters travel distance from the furthermost point. Okay, you got access lobby 45 meters. Now the fire lift, which is supposed to be in the FFAL, not more than 61 meters. Right, and then firefighting shafts with fire lifts not more than 61 meters from fire mains outlets, and this is Malaysian standards, and without firefighting lift, not more than 45 meters from the fire mains outlet. Right, now what we see here is that really this one is referring to a radial distance. In other words, you pull a straight line as the crow flies, and you draw a radial circle from the point. These one here are what I call the route distance. That means these are the actual travel distance. You connect a hose to that location, or you mark the physical people movement around the corridors, around corners of buildings, etc., etc. Right? So you combine both of these together. Just taking an example like here, if you take the firefighting access lobby from the door, okay, this will be the radial distance. This is how you check the radial distance. If you take the riser, again checking the radial distance, right? In this particular example, I've deliberately put the riser in that location, and you find that, okay, in this situation, the riser does not cover this area. So what do you do? Really, if you look at this plan, it's very, very easy. You move the riser from this corner to this corner, it would automatically cover. All right, but for illustration purposes, I'm just showing this example on how we do the basic checking. Right, so that area is not covered by this particular riser. Okay, then now the next thing to check is you go to a little flow chart. You start from here. So you ask yourself a question: is the fire lift within 61 meters? No. You immediately then add a firefighting access lobby, right? And then you ask the same question again. If the fire lift within 61 meters, yes, then you check the fire mains. Is the fire mains now within 61 meters? And if the answer is no, you install the fire mains in secondary protected stair, like in the example that we just mentioned. This example, right? If you insist that the fire mains is to be over there, it doesn't comply, say, for example, it doesn't comply with the 61 meters, then you add the secondary fire riser into the protected stair, right? That is what's prescribed in the bylaw, so you can do that. So if it does everything fine, you finish. So there are actually no contradictions between the Malaysian standards and the UBBL. It's just a matter of understanding what is the application. Okay, very quickly now.
Really,
okay, I do have again.
actually have
okay.
The last 15 minutes.
Yeah.
I hate to interrupt, but yeah, we do need to allow some time for questions.
Okay, very quickly. Okay, you'll be done. Okay, firemen, when they come in here, they actually, okay, this is how they work. Okay? I think the slide is quite self-explanatory. Very important then on firefighting on the inside for large floor plate buildings. These are all the prescriptions on the Malaysian standards. Breaching inlet BI, hydrants, maximum distance 30 meters, near edge, no closer than 2 meters, no more than 10 meters, 2 to 10, and this will be the inside of the building, the accommodation, right? And you are to allow the bombard vehicles to be able to get to maximum 18 meters from a breaching inlet, right? Where you have a protected lobby, you have a FFAL, that will be the relationship. These are the maximum distance allowed in terms of how we design for the access way, the near edge, and that. If you have a very, very big building where there are no risers, like say in a big giant warehouse, these are the prescriptions in the Malaysian standards that you have to comply with. You just have to check. These are fairly self-explanatory. Right. So again, in closing, I'll just say that are we still designing to minimum prescriptions? I will have to say we shouldn't be designing just to minimum prescriptions. We should be fully understanding of we should fully understand what is the building that we have designed, what are the fire risks, and plan and design all the appropriate fire safety devices and installations for it to work to comply with our design. All right. Okay. Thank you. All right, Husam, I'll send it back to you. Thanks.
Thank you very much. That's really, actually all these questions keep coming in, and I hate to interrupt the presentation because I don't want to interrupt the flow of what is being presented. I think we do have about 14 minutes, so that's not so much. And if I look at the first question actually came in through the chat by Gabriel Poo. Gabriel was asking what is the minimum width requirement for access road. So Datin Nawinade assisted with 6 meters. In your presentation, it says suggested is 4.5 meters. So
access road.
This would suggest that the access road.
Yes,
so the access road would be yeah. So this is because the question is access road. So it's 4.5, which is a suggested one. But obviously the bigger the better. And then we go to the Q&A. The first one is from Hui Fang. For the 2 plus 6 meter access way requirements, can the building facade protruding out by 2 meter after the clearance of 4.5 meter from the road level?
Okay.
So from the presentation just now, yeah.
Okay, I'll jump straight into it. The purpose of the 2 meter edge is to protect bomber or firemen or anybody from falling debris. So if your building projects out 2 meters, taking up the 2 meter edge, then falling debris will be falling out of the 2 meter. Right. Now, parallel to that, we all know about the BS 8414 test, the testing on the fire cladding. One of the criteria of the BS 8414 test is falling debris. The test sample cannot have debris falling beyond 2 meters from the face of the test rig. Right? So this 2 meter is integral to that. So yeah, I suppose there's nothing to particularly stop you from having things overhanging the top and all these things. But the important thing to note is that the wall above should not be contributing to falling debris, which will be going into the access way. Right? So it comes back to how you design your building. Just ensure that the facade of your building will not have falling debris.
Okay, and then by a question by Shukri Muhammad No, what is the minimum range between the fire hydrant and the building? So in your slide just now, it was 30 meters?
30 meters to the breaching inlet.
Okay. In the bylaw 2012, it does say 45 meter to the fire brigade access. So
but,
is there any...
Okay. 45 meters to the fire brigade access, but you refer to MS 1183, the last 3 slides that I was showing. That is actually the relationship between the external part of the building and the internal. The last 3 slides. Right. So, yeah, just configure the fire appliance access way, location of the hydrants, location of the breaching inlet, location of the access opening, and location of your, if you have it, your internal FFAL and the location of your landing valve on the ground floor of the FFAL, etc. Right, so that relationship is described in MS 1183 in my last 3 slides.
All right, and then a question by Chin Keng Ho. If fire accessway required as to be as island side, for example, is edge of accessway, which is more than 2 meter, less than 10 meter, need to be provided for the whole island perimeter?
Yes, by prescription, that's what it means.
Okay.
The island side means the entire perimeter must front an accessway, and the prescription of an accessway is that it must have an edge of no more than no less than 2 meters. So yes, by prescription, that is what it means.
Another question by Chin also, is there any distance limit between fire engine accessway to the firefighting lobby, because the firefighting lobby is designed further in from external? It seems not practical for firefighter to pass through long unprotected path to the firefighting lobby.
Mm-hmm. Yeah, this one would be shown in my second last slide on the relationship between the fire appliance accessway, hydrant, bomber, fire engine parking, and distance to the fire mains in the fire access lobby.
All right. Ahmad Anas, his question is, in your opinion, as an architect, what factor must be considered first? Is it design first, or is it safety first, or fire, or design first?
Of course, design first. We are all architects. Yeah, it's definitely design first. By all means, do not ever allow the uniform building bylaws to restrict your design. I've always used this analogy. Right? If you learn the bylaws, you learn especially the prescriptions of a UBBL, you learn it by heart, and you start designing your building to comply strictly with that set of laws. Your building will end up being a square box with island access and all the square openings, right? So that obviously doesn't work. By all means, we are architects, right? So please go ahead, do your design. It is after you do your design, then you have to then recognize where are the areas that you have to, where are the areas of fire risk, where are the areas that does not comply with prescriptive codes, right? Do the necessary adjustments, but you must start with design first. And having said that, right, our UBBL is purely prescriptive. So if you can come up with a design that, by virtue of its functional requirements and by virtue of its architectural splendor, you do require certain volumes, you do require a certain configuration that's way beyond the capabilities of the uniform building bylaws, the prescription of the uniform building bylaws, then that's where performance-based fire engineering approach comes in, right? You have to then compensate it with active systems, with your own, with the creation or the invention or the application of more precise manner to address the fire safety, right? So our technology is all up there, our knowledge is all around us. You just have to ask the right people and to get the right expertise. Yeah. So never ever use the bylaws to limit our design ability. Yeah. Always design first.
That's a good one. Another question by the same guy is, in your opinion, what is your opinion on our fire regulation right now? So do we need to revise the standard? Actually, the UBBL is currently under revision. But what's your take on this, Lee Siong?
We are always behind in our laws. That's why I'm always of the opinion that the bylaw should just remain as it is as a prescription, refer more to Malaysian standards, refer more to codes, because we work a lot faster with the codes, right? We work with Syrian, we work with Bomba, and we are adopting a lot of international codes. So the bylaw, because it's a document, it's a law. You have to go through parliament, you have to go through all those things. Yeah, it's too cumbersome. So we've always said that the bylaw, we should remove prescription from the bylaw, and the bylaw should make references to empower the use of specific standards and codes. Then we can work on the standards and codes a lot faster. Yeah. But having
Yeah.
said that, our current knowledge of fire safety in Malaysia is actually very, very high. Yeah, we do have a group of very experts and well versed people. Malaysia has got a very, very high content of buildings that are designed to comply with international codes. So just look at all our foreign direct investment buildings owned by foreign direct investment companies, all our high-tech factories and the, 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 um, the electronics industries, the food and beverage industries, and oil and gas industries, and all these things. All these things are designed to international standards, way, way, way beyond the prescriptions of our uniform building bylaws, right? And we've got a very, very high expert group here in Malaysia itself, who are very, very conversant with those things. So yeah, our access to standards and technology is all available, right? So yeah, don't have no worries about that. In terms of the limitation of the bylaw and all, we just have to work around it.
Yeah, just to update the participants of this talk. Actually, with the revision of the UBBL 2020, Bomba and also some of the other regulatory bodies, their means is actually to get the bylaw to be passed out quickly. So once that is done, they are in the process of developing the Malaysian Fire Code, which can be written in a more free manner that doesn't require the rigorous lawmaking process like a UBBL. So we do have the UBBL and we do have the 1183. And very soon we might be having our fire code that is empowered by the fire Bomba Act. Okay, so we have the last 3 minutes. I'm going to go to the chat now. Let's see. We have Gabriel. She seems to be more aware. She seems to be aware of the requirements from the SCDF. Understand that the building bylaw do not require to have fire access panel on the building facade. High-rise commercial buildings with center core and full glass wall facade. Do we need to provide fire access panel for those kind of buildings? And can use open basement ramp with gentle, slow fire engine accessway. So I'm not sure whether you're reading this, Lee Siong, and if you understand the question, probably you can.
It's not on the chat, is it? Or but never mind.
Oh, it's inside the chat. Yeah, it's not in the Q&A. It's inside the chat.
Okay. Never mind. The as I mentioned, the access openings is not in the UBBL, so it's not mandated by law. But we are fully aware of the importance of that item, and Bomba in very specific projects do, and they have made specific requests for that. Yeah, they're very, very specific projects where a particular fire risk or a particular situation is identified. Bomba has and the Bomba have made those particular requests. But yeah, again, like as I mentioned, our bylaws are not exactly a very, very thorough document as it stays now. So we should be designing beyond it now.
Okay. We have one Song Wei in the chat asking on the development of a bigger scale, planning for road access to the development on road of say U2, U3 for housing development on slope terrain. Will the 1 to 15 or the 1 to 8.3 road gradient apply? So which one does it apply for?
Okay. Access road is very distinct from access way. So access way is about a very specific design for bomber parking, bomber staging. Access road is just a road to get access to the accessway. In residential developments, you would have noticed that the building volumes of terrace houses do not require access way. So what are we providing? We're actually providing access roads. Yeah. So if you have a terrace house development on a sharp slope, yeah, you provide the hydrants as is required, but that is an access road. So just for bomba to be able to get to you, but not necessarily for it to function as an access way.
All right. So I think that's the time that we have for today. There's a few other questions in the Q&A. Some people are asking for the recording. I'll check with the organizer. And some of the questions that are left there in the Q&A, I'll see how we can actually answer them and have it available to you. So I would like to, we will have to end the session because time is finished. I would like to thank all the participants who has dialed in, and obviously a very thanks to you, Architect Chong Lee Siong, for giving us a talk. It is always very interesting and very insightful to hear all these requirements on fire. Probably just a last word from you before we end the session.
Oh dear. Okay. Yeah, we are architects, as I mentioned earlier. Do not ever use the bylaw as an excuse for the reduction of our design capabilities or the reduction of our final product. It is not meant to be that way. I always lead it by design. We are architects. Create the best building you can have, right? Then just use the bylaw as a basis for us to analyze and to use it as a basic benchmark for us to check in terms of fire safety compliances and all that. And in situations where you can't meet it, don't always go and ask Bomba for waivers of things, because we don't waive safety. Safety is really non-negotiable. You don't waive it. What we have to do is create your response. If you have a deficiency, look for a response. Look for a way to address it, rather than going up to Bomba. Oh, Bomba, I can't do this. Can I waive it? Okay, let's take on the approach that we are here to design first the best architectural buildings you can ever have. Then the buildings ought to be the safest buildings you can ever design. Right? That would be my take.
Very well said. Well, thank you again, everybody, and thank you very much, Architect Chong Lee Siong, for a very insightful session.
Right. Thank you all for having me. Thank you. Really appreciate
it. Thank you, and have a good day for CPD Unlimited until this afternoon. Goodbye, everybody.
Okay. Goodbye. Thank you all.